Heat a bar of iron and it glows. Red, then orange, then yellow-white. Any iron, any ceramic, anything at that temperature, the same color, the same glow. By 1900, that glow had been measured to within 1%. The best theory in physics predicted it infinitely wrong. Literally, infinitely. In Berlin, Otto Lummer and Ernst Pringsheim traced the spectrum of heated bodies with exquisite care. Smooth, hump-shaped curves, reproducible to a percent. The data was solid. Every temperature drew the same shape. A hump. Hotter meant taller, with the peak sliding toward blue. Explaining this hump was the whole game. The classical argument was clean. Take a glowing cavity. Count the ways light can vibrate inside it. That count is pure geometry. Nobody disputed it. Then classical physics pays every vibration the same wage. kT of energy, each, equal shares. The same rule that ran the steam age flawlessly. Modes times wages gives the Rayleigh-Jeans law. At long wavelengths it fits the Berlin data. Then the mode count keeps climbing, and the prediction runs away. Add every frequency and the total is infinite. Taken literally, a hot poker should flood your living room with ultraviolet. It plainly does not. So which assumption breaks? Not the counting. Not equal shares. Gases obey it beautifully. The killer is subtler. That energy flows continuously, in any amount whatsoever. Max Planck was not trying to start a revolution. He was trying to fit a curve, working backward from the data and honest about it. The only fix that worked, the cavity's oscillators cannot hold just any energy, only whole steps. 0, 1, 2, 3 chunks, nothing in between. One line carries the revolution, E equals h nu. A chunk's energy is the light's frequency times a new constant of nature. That equals sign is a ban. E, the energy of one chunk. Nu, the light's frequency. And h, Planck's constant, the exchange rate between them. 10 to the minus 34. Tiny. At a forge's temperature, red chunks cost almost nothing. Ultraviolet chunks cost 50 times the thermal budget. The cavity cannot pay. High frequencies stay dark. Planck's formula traced the measurements within 1%. Where classical physics worked, it agrees exactly. Where classical physics exploded, it dies away exponentially. No catastrophe. In the ultraviolet, the classical prediction is off by 20 orders of magnitude. Not wrong by a little, wrong by a 1 with 20 zeros. He read it to the Physical Society on December 14, 1900. His constant within 1% of today's value. It reads like an apology, not a manifesto. Planck spent years trying to remove the chunks from his own formula. It cannot be done. Who was this reluctant revolutionary? That's a story of its own. Next, light itself comes apart in chunks, the photoelectric effect.